formed with the evolution of a gas. What type of change is it? Explain. You see, we have studied about the reaction of baking soda and vinegar in this chapter, if you remember. We have seen when vinegar, CH3COH, which is an acid, reacts with baking soda, carbon dioxide is formed also with water and sodium acetate, that is CH3COL. Correct? Now in that case, we have seen when baking soda reacts with acid, a gas being evolved is carbon dioxide. Correct? So the answer of this question is when baking soda reacts with lemon juice, when baking soda is mixed with lemon juice, bubbles are formed. Those bubbles are of which gas? Carbon dioxide. And the evolution of gas, the gas itself is carbon dioxide. We have also learned that when baking soda reacts with acid, a hissing sound is produced. Hiss. That hissing sound is produced because carbon dioxide, when forms, purges out from the mixture, and bubbles are formed because of it. And that particular gas is carbon dioxide. So what type of change is it? It is a chemical change because new substances are formed. Carbon dioxide, water, and also sodium acetate we have seen in that case of vinegar. So when baking soda reacts with lemon juice, or when baking soda is mixed with lemon juice, bubbles of carbon dioxide is formed, and this is a chemical change because new substances are formed. Now if you remember, apart from this question, if you remember, to check whether the gas evolved is carbon dioxide or not, we have passed carbon dioxide into lime water and it turns milky. We have seen in the earlier question also, where it was fill in the blanks. What happens when carbon dioxide is passed through lime water? It turns milky due to the formation of calcium carbonate, which is a specific test for checking whether the gas evolved is carbon dioxide or not. So the answer of this question, I repeat again, when baking soda is mixed through with lemon juice, bubbles of carbon dioxide is formed, bubbles of CO2 are formed, and this type of change is actually a chemical change because new substances are formed. And to check whether the gas evolved is carbon dioxide or not, if you pass the carbon dioxide in lime water, it will turn milky due to the formation of white precipitate, white solid particles of calcium carbonate. So fifth question of this exercise is, when a candle burns, both physical and chemical changes takes place. Identify these changes. Give another example of a familiar process in which both physical and chemical changes takes place. Now if you see the first part of this question, when a candle burns, both physical and chemical changes takes place. How? Let us understand. We have already seen this example, and I have already explained you that burning of wax or burning of a candle is different from melting of a wax or melting of a candle. Now if you take a candle, if you light the candle, you can see after the candle completely burns, there is very small amount of wax being collected at the bottom of the that particular candle. The volume of, or the solid part which was actually used for burning was not same as what we have collected at the bottom. The reason is very major part of that candle burns away, which is a chemical change, that is burning of wax or the burning of candle, and very small amount of that candle or wax is being melted and collected at the bottom in form of solid, that is melting of wax is a physical change. How it is a physical change? You have changed the state of a solid candle or solid wax into liquid form, and when the temperature goes down, as it moves downwards, the temperature goes down and it again solidifies to form the same wax of different shape. Correct? So most part of that wax or the candle goes for burning, and a small amount or small part of that wax or candle goes for physical change and is being collected in form of solid at the bottom. So burning of wax is a chemical change, whereas melting of wax is a physical change. Why physical change? Because you have changed the state and the shape of that wax or candle. Now the second part of the question is, give another example of a familiar process which undergoes both physical and chemical changes. You see, if you take a piece of wood and if you try to burn that wood, the wood will have some water particles into it, some moisture into it. So if you burn a piece of wood actually two things are happening. That water molecules absorbed in that part of wood, that in that piece of wood, is actually vaporizing to form water vapors. So it means you have vaporized, you have converted liquid form of water into gaseous form of water. It means you have changed the state of a component, that is water, from liquid to gas. It means you have changed the physical properties, but not internal properties of water. So it means it is a physical change. What is physical change? Evaporation of water while burning that wood from liquid state to vapor state, correct? Gaseous form. Whereas wood, which is basically mainly carbon, so you are burning carbon in presence of oxygen to form carbon dioxide and ashes. That is a chemical change. Why? Because new substances are formed, and also this process is irreversible because you cannot combine carbon dioxide and ashes again to form that original wood. So in this example, burning of wood, the second part of this question, the example, burning of wood, there are two processes taking place. One is a physical change in which the moisture content, the water inside the wood, has been evaporated to form water vapors, liquid form being converted into gaseous form. Change of state means physical change. And the second part, the second case is burning of carbon, that is burning of wood to form carbon dioxide and ashes, which is a chemical change because new substances are formed and you cannot combine carbon dioxide and ashes to form again that piece of wood. So it is a chemical change and also irreversible at the same time. So this was the fifth question of this exercise. Now moving further in this exercise, the sixth question. The sixth question is, how would you explain that the settling of curd is a chemical change? Now if you remember in this chapter, we have seen different examples of chemical change, and also we have seen that formation of curd from milk is a chemical change. I will explain you how it is a chemical change. If you see, if you take some amount of some volume of milk, say 100 ml of 100 milliliter of milk in a bowl, and if you try to form curd from it, then you cannot obtain milk again from that curd, back from that curd. Why? Because this process is irreversible. Now this process is irreversible, and also a new substance has been formed from the milk, that is curd. So settling of curd or the formation of curd from milk is basically a chemical change. Why? Because new substance has been formed and internal properties of milk has been changed. Because since chemical change, when internal properties of a substance changes and new substances are formed, it is said to be a chemical change. So in this question, settling of curd or the formation of curd from the milk is changing the internal properties of milk, and a new substance has been formed, that is curd. So since this process is irreversible and a new substance has been formed, this settling of curd can be explained as, or can be termed as, a chemical change. So how you will write the answer of this question? Settling of curd means formation of a new substance, that is curd, from milk, and since you cannot obtain milk back from the curd, and this it makes the process as irreversible. So since the process is irreversible and new substance has been formed, settling of curd is a chemical change. Now if we see the next question, the seventh question is, explain why burning of wood and cutting it into pieces are two different types of changes. Now I will explain. We have also seen the particular example of burning of wood in chemical change. We have studied that, and in the fifth question also we have seen that give a familiar example where both physical and chemical changes takes place, and I have given you the example of burning of wood. In this question also I will explain you how burning of wood and cutting it into pieces are two different type of changes. See, burning of wood means you are going to change the internal properties of wood into some different properties, and new substances will be formed. How? If you burn wood, it will be converted into ashes, and also CO2 will be released, because wood is mainly carbon. So if you burn wood, carbon dioxide gas is released and ashes are left behind. So you see, in this process new substances are formed, and also this process is irreversible because you cannot combine CO2 gas with ashes to form again the same piece of wood. So burning of wood is a chemical change because new substances are formed and the process is also irreversible at the same time. Whereas if you cut wood into different pieces, you have changed the physical properties of the substance. How earlier the size was big, maybe the shape was different. Now the sizes of pieces are small and the shape may also change. So you have changed the shape and size of wood into smaller ones, but you have not changed the internal properties. It is wood now also, it was wood earlier also. So it means changing the state, shape and size, which is changing the physical properties of a substance, is termed as physical change. So cutting of wood into pieces means you are changing the shape and size of wood, but you are not changing the internal properties of that particular wood. So it means it is a physical change. So burning of wood is a chemical change. We have just understood that part. Burning of wood is a chemical change, but cutting of wood into pieces is a physical change. Now the 8th question of this exercise is, describe how crystals of copper sulfate are prepared. We will understand the answer of this question in form of an experiment and activity. The first step to understand how crystals of copper sulfate are prepared or are formed, you take some water in a beaker. The second step, you add a few drops of dilute sulfuric acid to it, and the third step, you let the mixture of water and few drops of sulfuric acid to boil. Once the water or the solution starts to boil, you add the powder of copper sulfate into it with continuous stirring. Now, what will happen when the water will start to boil along with sulfuric acid, dilute sulfuric acid and powder of copper sulfate? You will see at the bottom some crystals will start appearing. The moment the crystal starts appearing, you allow the solution of water, dilute sulfuric acid, drops of dilute sulfuric acid and copper sulfate powder to cool, and then filter the solution. Once you filter the solution, and if you take the filtrate on some plate, you can see the crystals of copper sulfate being formed. So this is how you can prepare the crystals of copper sulfate. I repeat the steps. You take some water in a beaker, you add few drops of dilute sulfuric acid, you allow the water, the mixture, the solution of dilute sulfuric acid, few drops of dilute sulfuric acid in water to boil, and then you add the powder of copper sulfate into it with continuous stirring. While continuous stirring the mixture, you can see crystals appearing at the bottom of the beaker. You cool the mixture, you cool the solution, and you filter the solution. After filtering the solution, you can see the blue crystals of copper sulfate being formed on the plate where you have kept the filter. Now if you see the next question, the 9th question, the question is, explain how painting of an iron gate prevents it from rusting. Explain how painting of an iron gate prevents it from rusting. Now we have seen rusting, we have studied rusting, we have seen there are many ways to prevent rusting of iron, correct? Before answering this question, let us understand what is rusting of iron. Rusting of iron is formation of iron oxide from iron. Iron is grey-black metal in color. When it comes in contact with oxygen or moisture present in environment, it forms iron oxide, which is reddish brown in color, and it eats the parent metal. It is harmful for the metal oxide, metal gate or metal rod, correct? Now the question is, explain how painting of iron gate prevents it from rusting. Now if you apply paint, any sort of paint on say that particular iron gate outside your house or office or any door, an iron gate, then what happens is it does not allow the iron to come in contact with oxygen or moisture present in environment to form iron oxide. Why? Because rusting is a harmful process. It eats the metal, it will create losses, and you have to replace the iron gate or the iron rods again once the iron oxide or the rust has been formed. So if you apply paint on the iron gate, it prevents the iron metal to come in contact with the oxygen or the moisture present in the environment directly, and helps to prevent the formation of iron oxide, which is reddish brown in color and is also called as rust of iron. So this is how painting prevents, or painting helps us to prevent rusting of iron gate.
No more spending your energy and money on coaching classes, or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now the 10th question of this exercise is, explain why rusting of iron is faster in coastal areas than in deserts. Now before answering this question, let us understand what are coastal areas, what are the conditions there, and what are deserts and what are the conditions there. See, in coastal areas you have presence of sea and ocean water, correct? If you have presence of sea and ocean water in coastal areas, it means there will be higher content of moisture in the air or the environment. Why? Because continuously that water of the surface of sea and ocean water vaporizes and increases the content of moisture in air present over sea or ocean water or in coastal areas. Whereas if you talk about deserts, you have very dry and hot conditions there, which means you will not be having so much moisture content in the air there because of dry and hot conditions. Now iron get rusted when it comes into contact with oxygen or moisture present in the environment, which we have seen in the chapter also, we have seen in the earlier example so many times, that iron gets rusted when it comes into contact with oxygen and moisture present in the environment. It forms iron oxide, which is reddish brown in color. Now if we talk about coastal areas, moisture content is high. So it means if you have iron present in coastal areas, it will be exposed to larger quantity of moisture present in the environment, and will be corroded easily or will corrode continuously because the moisture content is high in those areas. Whereas if you talk about deserts, since the moisture content is less and iron is not being exposed to moisture content easily because due to the absence or the less quantity of moisture in those areas, it will not get rusted or corroded easily. This is why iron gets corroded easily, iron gets rusted easily in coastal areas because of the high percentage of moisture in the air due to the presence of ocean and sea water, whereas iron do not get rusted easily or faster in desert areas because of the low moisture content in those areas. So it means if the content of moisture in air is more, iron gets corroded or rusted faster, and if the moisture content is less, it will be corroded or rusted at a less rate. So iron gets rusted faster in coastal areas than in desert areas. Now if we see the 11th question of this exercise, the question is, the gas which we use in the kitchen is liquefied petroleum gas, LPG, which we all know actually it is called as LPG. So the question is, the gas which we use in the kitchen is liquefied petroleum gas, LPG. In cylinder it exists in the form of a liquid. When it comes out, it becomes a gas, that is given as change A, and then it burns, which is given as change B. Now also written is, the following statements pertain to these changes, choose the correct one. Correct? We have to choose the correct option. Now the options given are, process A is a chemical change, option B is process B is a chemical change, option C is both these processes A and B are chemical changes, and option D is none of these processes is a chemical change. Now you understand, when this LPG, which is in liquid form inside the cylinder, when this LPG, which is in liquid form inside the cylinder, comes out from the cylinder, it becomes a gas. So basically we have seen the change of state from liquid to gaseous form, but the compound is same, LPG, liquefied petroleum gas. When it comes out from the cylinder in form of gas, that particular change, which is given as change A, is actually a physical change. Why? Because the physical properties are changing, but the internal properties of that particular compound LPG will remain same for that particular change A, where change of liquid to change in gas of LPG is given. Correct? State is changing, physical property is changing, but the internal property will remain same. So change A is a physical change. But if you burn LPG, if you burn that gas, which is actually mainly natural gas, or you can say methane gas, CH4, if you burn that gas, LPG gas, liquefied petroleum gas, it will form CO2 or will liberate water in forms of vapors if it has moisture content into it. So change A is a physical change where state of the LPG is changing from liquefied petroleum gas, liquid form to gaseous form. State is changing, but in change B, it is a chemical change. Why? Because new substances will be formed and the internal properties of that LPG will change. So if you see the options are, the first option is process A is a chemical change, but we have just learned that process A, the change A will be a physical change because the state is changing, liquid form to gaseous form. So process A is a chemical change is a wrong option. If we talk about process B is burning of the gas. Burning of the gas will mean that new substances will be formed, and also at the same time it is irreversible. It cannot be reversed back to form LPG again. So change B is a chemical change. Chemical change means new substances are forming and the process is also irreversible in this particular case. So it means option B is right. Change B or the process B is a chemical change. So you don't have to go to C and D position because C option says both the processes A and B are chemical change, but we have just seen that change A or the process A is a physical change but not chemical change. So both the process A and B cannot be chemical changes. Also the option D says none of these changes is a chemical process or chemical change, but we have just learned that process A is a physical change whereas process B is a chemical change, and since process B is a chemical change, option D is also a wrong option. So among the four options which we have seen, the B option is right, that is process B is a chemical change. I'll explain it again. Process B is a chemical change because the gas, when it comes out from the cylinder, is being burned, and burning of the gas will lead to formation of new compounds, and also the process is irreversible at the same time, and formation of new compounds tells us that the process should be a chemical change. So change A is a physical change and change B or the process B is a chemical change. The answer is option B. So finally we come to the last question of this exercise, question number 12. The question number 12 is anaerobic bacteria is used to digest animal waste to produce biogas, which is given as change A. Anaerobic bacteria digest animal waste to produce biogas, which is given as change A. The biogas is then burned as fuel, which is given as change B. The following statements pertain to these changes. Choose the correct one. So in this question, there are two different changes, change A and change B. The change A is anaerobic bacteria digest animal waste to produce biogas, whereas change B is the biogas is then burned as fuel. Now friends, if you see change A, in change A also and in change B also, in both the processes, new substances are being formed. If anaerobic bacteria digest animal waste to produce biogas, then biogas is a new substance and you cannot convert biogas back again to animal waste. It is irreversible at the same time. So since new products are formed, internal properties of the earlier product is being changed. Internal properties of animal waste has been changed to produce biogas, which has different properties from animal waste, and also at the same time the process irreversible. It means change A is a chemical change but not physical change. If we talk about change B, then we can obviously understand if you burn biogas, new substances will be formed, correct? New substances, new gases will be released and heat will be produced. So obviously internal properties of biogas are changed to produce new substances, and at the same time the process is irreversible. It means change A and change B both are chemical changes. So if you see the options, if you see the 4 options given here, which are similar to the options given in question number 11, but the answer is not similar, although the first option is the process A is a chemical change, process B is a chemical change, both the process A and B are chemical changes, and the last option is none of these processes is a chemical change. Now friends, in these 4 options you can understand process A is also a chemical change, but process B is also chemical change. The first option says only process A is a chemical change, whereas the second option says only process B is a chemical change, and the third option says both the processes A and B are chemical changes. It means, since we have understood that change A, the process A is also a chemical change and process B is also chemical change, the answer should be C option. Both the processes A and B are chemical changes. So in this question you should understand why both the processes A and B are chemical changes. Why? Because the internal properties of animal waste has been changed to produce biogas, and also at the same time the process is irreversible. Since the internal properties are changing, change A should be a chemical process or chemical change. Also in process B, when biogas is burned, since burning of biogas produces new substances and energy will be liberated, and at the same time the process is irreversible, change B is also a chemical change. So both change A and change B are chemical changes, and that is why the answer is option C. Both the changes are chemical changes. Both the processes A and B are chemical changes.